Understanding the basics, population, and census inquiry. When embarking on any research endeavour, it is crucial to clearly define the target group under investigation. This group is known as the population, encompassing all individuals, objects, or units relevant to the research question. For instance, if we aim to study the voting preferences of American citizens, our population would comprise all eligible voters in the United States. In an ideal scenario, researchers would gather data from every single member of the population, a method known as a census inquiry. Imagine attempting to interview every eligible voter in the United States, a daunting and resource-intensive task. Census inquiries provide a comprehensive snapshot of the entire population, leaving no room for sampling error. Section 2. The challenges of census inquiries. While census inquiries might seem ideal for obtaining complete and accurate data, they often face significant limitations, particularly when dealing with large and diverse populations. The sheer scale of a census can be overwhelming, demanding extensive resources in terms of time, manpower, and finances. Imagine the logistical nightmare of coordinating interviews, distributing surveys, and compiling data from millions of individuals. The time required to conduct a full census can be prohibitive, especially when dealing with time-sensitive research questions. Moreover, ensuring a high response rate from every member of a large population is a significant challenge. Section 3. Why sampling matters. Given the limitations of census inquiries, researchers often turn to sampling as a practical and efficient alternative. Sampling involves selecting a smaller, more manageable subset of the population, known as the sample, which is carefully chosen to represent the characteristics of the larger group. By studying this representative sample, researchers can make inferences and draw conclusions about the entire population without the need to collect data from every single individual. Sampling offers a cost-effective and time-saving approach to research, allowing for quicker data collection and analysis. Section 4. Probability versus non-probability sampling. When designing a sampling strategy, researchers must choose between two fundamental approaches: probability sampling and non-probability sampling. These approaches differ in how sample members are selected and the implications for generalizability. In probability sampling, every member of the population has a known and non-zero chance of being selected for the sample. This random selection process ensures that the sample is representative of the population, allowing researchers to make generalizations about the larger group with a certain level of confidence. On the other hand, non-probability sampling relies on non-random methods for selecting sample members. This approach often involves convenience or purposive selection, where researchers choose individuals based on their availability or specific characteristics. While non-probability sampling may be more convenient in certain situations, it does not guarantee representativeness, making it difficult to generalize findings to the entire population. Section 5. Deliberate sampling, a purposeful approach. Deliberate sampling, also known as purposive sampling, is a non-probability sampling technique where researchers handpick individuals for the sample based on their specific knowledge or expertise. This approach is particularly useful in exploratory research or when studying rare phenomena. For example, if we were interested in understanding the experiences of cancer survivors, we might deliberately select individuals who have undergone treatment and can provide in-depth insights into their journey. Deliberate sampling allows researchers to gather rich qualitative data from individuals who can offer unique perspectives. Section 6. Simple random sampling, leaving it to chance. Simple random sampling is the most straightforward probability sampling technique, where every member of the population has an equal chance of being selected. This method ensures that the sample is truly random, minimizing the risk of bias. To conduct simple random sampling, researchers often use random number generators or tables. For instance, if we had a list of 1,000 students and wanted to select a random sample of 100, We could use a random number generator to choose 100 numbers between 1 and 1000, corresponding to the students on the list. Section 7. Systematic sampling, a structured approach. Systematic sampling offers a more structured approach to probability sampling. In this method, researchers select every KTH individual from a list of the population where K is a predetermined sampling interval. For example, if we had a list of 1,000 students and wanted to select a sample of 100, we could choose every 10th student from the list. Systematic sampling is often easier to implement than simple random sampling, especially when dealing with large populations. However, it is crucial to ensure that the list is not ordered in any way that could introduce bias. Section 8. Stratified sampling, ensuring representation. Stratified sampling is a probability sampling technique used when the population can be divided into subgroups or strata based on specific characteristics, such as age, gender, or ethnicity. Researchers first divide the population into these strata and then randomly select individuals from each stratum to form the sample. For example, if we were studying voting preferences and wanted to ensure representation from different age groups, we could divide the population into age strata, like 18 to 24, 25 to 34, 35 to 44, and so on, and then randomly select individuals from each age group. Stratified sampling ensures that the sample reflects the proportions of these subgroups in the population. Section 9. Quota sampling, balancing practicality and representation. Quota sampling is a non-probability sampling technique that shares similarities with stratified sampling. Researchers first identify relevant subgroups within the population and determine the desired proportion of each subgroup in the sample. However, instead of randomly selecting individuals from each subgroup, researchers use convenience or purposive sampling to fill the quotas. For example, if we were conducting a survey on consumer preferences and wanted to ensure a certain number of responses from different age groups, we could set quotas for each age group and then approach individuals who fit those criteria until the quotas are met. Quota sampling is often more practical than probability sampling in terms of time and cost, but it does not guarantee representativeness. Section 10. Cluster and area sampling, efficiency in field research. Cluster sampling and area sampling are probability sampling techniques commonly used in field research, particularly when dealing with geographically dispersed populations. In cluster sampling, researchers divide the population into clusters such as geographical regions or schools, and then randomly select entire clusters to be included in the sample. For example, if we were studying the prevalence of a particular disease in a city, we could divide the city into neighborhoods or clusters, and then randomly select a certain number of neighborhoods to study. Within each selected cluster, we would collect data from all individuals or a random sample of individuals. Area sampling is a specific type of cluster sampling where the clusters are geographical areas. This technique is often used in surveys and public health research. Section 11. Advanced techniques, multi-stage and sequential sampling. In more complex research designs, researchers may employ multi-stage sampling or sequential sampling. Multi-stage sampling involves selecting a sample in multiple stages, often using different sampling techniques at each stage. Sequential sampling involves collecting data in stages and making decisions about whether to continue sampling based on the data collected at each stage. This approach is often used in quality control or when monitoring a process over time. Section 12. Mixed sampling and the role of non-random sampling. In some cases, researchers may employ mixed sampling, which combines elements of both probability and non-probability sampling techniques. This approach can be useful when certain subgroups within the population are difficult to reach using probability sampling alone. While probability sampling is generally preferred for its ability to ensure representativeness, non-random sampling can be a practical and valuable approach in certain situations. For instance, when conducting exploratory research, studying rare phenomena, or when resources are limited, non-probability sampling can provide valuable insights.